Hello students, today we will see from the gas laser category the second one, which is the nitrogen laser. So moment I use the word nitrogen laser, this is comes under the category of vibronic lasers. Now first we'll see what is vibronic means. So vibronic is relating to transition between the molecular energy states when modified by the vibrational energy. Right? So this basically comes under the category of vibrational levels of different electronic states. Okay, and these lasers oscillate in the ultraviolet range. Okay, so now we'll see the meaning of vibronic laser also. So lasers based on the gain media with large gain bandwidth. That's the reason this is called as the vibronic laser. Now these lasers basically show extremely high gain, what I just mentioned, extremely high gain even in the absence of a resonant optical cavity. Till now we have seen everywhere you had a cavity and the mirrors and the normal procedure, but this, even though without a resonant cavity, show the performance of high gain. In this, the stimulated emission and the laser action occurs in these lasers in a single pass through a active medium. Okay, and the radiations of this sort is basically known as super radiance. This is a very good term, okay, coined by the scientist named Dick. Okay, now we'll see directly to the energy level diagram of this laser. Okay, so over here what you observe for the N2 molecule, the laser oscillations. Okay, the laser oscillations is obtained on the transition from the lowest vibrational level, nu is equal to 0, of the excited state C3 pi u to the lowest level of the electronic state B3 pi g. Okay, this is my C3 pi g, and this second one, even though it's written here, it is over here. This is B3 pi g, corresponding to what is the wavelength over here given. The wavelength over here is 337 nanometers. Okay, now this transition is more favored. Now there are some reasons behind why it happens only from C3 pi u to B3 pi g for this level. Okay, now the first reason for this is the minima of the potential energy. This is energy versus nuclear radiance. Okay, so the potential energy curves of the two states, this C3 pi u and B3 pi g, are at about the same internuclear distance or a nuclear distance. Okay, and this is a must or a requisite for satisfying a very important principle called as Franck-Condon principle. Okay, and the second condition for the level nu is equal to 0 is an electronic state is most populated, and therefore the transition is very intense. Okay, now even though we need to mention that the lifetime of this C3 pi u state is 40 microsecond. C3 pi u is 40 microsecond, which is much smaller than the B3 pi g state, which is only 10 microsecond. Okay, so this becomes very small, 40 microsecond, and this is 10 microsecond. Okay, and therefore the population of the two levels can only be transiently inverted. Okay, and the inversion is rapidly destroyed by the accumulation of molecules in the lower level. Okay, so it can be made to operate on the pulse basis. So here we are written the pulse nitrogen laser used. Okay, and this provides the duration of electric pulse is shorter than 40 microsecond. Okay, and the laser pulse, this laser pulse lasts only 7 to 10 seconds, very small time, and it is self-terminating. So here I just mentioned the points. It is vibronic laser. The wavelength in this case is only 337 nanometers in ultraviolet range, is self-terminating, and this is a pulsed nitrogen laser. Okay, so this diagram, okay, and these 4 points covers whatever I mentioned just now. Important part is over here. Why only this transition? Because of the Franck-Condon principle. That is a must. Okay, and what does that say? That the minima, that is this point of the potential energy curve of these two states, which two states, C3 pi u and B3 pi g, is or are at about the same internuclear distance, which is a must for the Franck-Condon principle. Okay, and what we said, one more thing, the lifetime of this C3 pi u is 40 microsecond, which is smaller than that for the B3 pi g, which is 10 microsecond. Okay, so all these becomes very important points to study. Okay, now we'll go to the schematic diagram for the nitrogen laser. So this nitrogen laser is in this fashion. One of the way we can do it in this fashion. Okay, so what is happening over here? The excitation of nitrogen molecule. So here first we'll see what is there in this diagram. So here they say that this is a region where you have a gas mixture, and the gas mixture contains 40 millibar of nitrogen and 960 millibar of helium. Okay, now what is 1 millibar? 1 millibar is 100 pascals. Okay, so they are mixed about nitrogen and helium. In this case, they use the transverse electric field laser configuration. Okay, so what you have basically, you have a spark UV source and a spark power supply, due to which one can produce a very high spark over here. Okay, UV source is basically used. Now this is done due to what? When the spark is going to produce, there will be discharge taking place by the action of the switch. So when the switch is pressed, what is going to happen? Due to the discharge electrodes, these two electrodes, there will be a huge discharge which will help the molecules to move to the upper level, what we just mentioned in the energy level diagram. Okay, now we'll get back to the description. So what happens over here? The excitation of the nitrogen molecules, nitrogen molecule is 40 millibar. Nitrogen molecules comes through its collision with the free electrons. Okay, so the probability of excitation of nitrogen molecules from its ground state, okay, from its ground state to the state, which one? C3 pi u, by electron impact is much greater than that to the second one, B3 pi g state. Okay, so the electric field which I showed over here, okay, the electric field is applied perpendicular to the direction of stimulated emission, and this arrangement allows a large gas volume to be excited at around 20 kV. Okay, yeah, 25 kV. Okay, if the electrodes were placed at the end, a voltage at least 25 times larger would have required. Okay, so if the electronic pulse is made to travel in synchronism with the laser pulse, it is possible to achieve a high gain even without a mirror. This is a must. How can you get a high gain? Because it's a specialty of this nitrogen laser, without a mirror. Okay, so what do? They ensure that the voltage pulse applied to the plates, okay, travels along the axis at the same velocity as the light pulse. So in this case, what happens basically? The current of several thousand amperes per square centimeter in nitrogen with suitable pressure. What is the usual pressure they apply? 20 torr to around 30 torr. Okay, which excites several rotational lines of the, what we said, C3 pi U to B3 pi G band to super radiance, providing a peak power of around 20,000 watts. That high power is used. Okay, so designs usually several dozen cables to supply the transverse currents have reached powers up to 1 megawatt. Okay, 1 megawatt in pulses for only for the 10 nanosecond. Okay, it is 1 megawatt in pulses for the 10 nanosecond with a repetition rate, pulse repetition rate of 100 hertz. Okay, so what we can say about it, the main property, the attractive properties of this nitrogen laser is what? Nitrogen lasers that make it suitable for various types of investigation concerns its short wavelength. Okay, very short wavelength, we have spoken about it earlier also. I'll just get back to that. So the wavelength is in nanometer, 337 nanometers, high peak power, a short pulse duration, and high repetition rate, and good amplitude stability. All these are the main properties of this nitrogen laser. Along with that, these 4 points are again must to know. Vibronic laser, wavelength is only 337, self-terminating, and pulse nitrogen laser. Okay, if you want to write even this diagram, it's again same way. This is your ground state E1, like which is over here. Okay, this is E2, which is my middle one, this B3 one, and this is E3. Okay, so and over here first the molecules will reach over here, and from E3 they'll directly come back to, few will come back over here, and they will come to E2 level. And at this level itself, when you have a more population inversion will take place, you get a laser pulse of 337 nanometers, which is in the ultraviolet range. Okay, and then finally they'll come back to the ground state. Okay, this is what is happening as far as the fourth laser in the gas laser category is concerned. After finishing HENE, CO2 and examer, today we just finish with the nitrogen lasers. Okay, go through it. Anything not clear, feel free to ask. Okay, thank you very much.